Well, good evening. So the title of my talk is "Do you know what you are feeding?" And so I'm going to share some work that we've done on a couple different projects over the last year or so, where we really kind of dive into what it is that our cattle are actually eating. And we'll talk a little bit about some conserved forage quality as well at the very end. But when we start thinking about what cattle actually eat, this is kind of a saying that I learned in graduate school as a student, and it really does hold true, is that for every ration that exists, there's really 4 different diets that exist, and that's the diet that's formulated. So myself as a nutritionist or any other nutritionist has a computer program that we formulate rations on, and so we formulate that based on either book values or actual analyzed values of ingredients, more preferably. And then we have the diet that actually gets mixed, the diet that then actually gets delivered. So there's can be some steps in between there where diets maybe don't stay mixed together, they settle out and that kind of thing, so some changes can occur. And then ultimately the diet that the cattle eat. And so when I really think about that, I think about situations where cattle start to sort. And so anywhere along this kind of step from formulation to cattle consumption, there's opportunity for error. And so a lot of times, we want to just quickly get a ration. We use a lot of co-product feeds, and we don't necessarily get those analyzed, and we rely on book values. And so I was curious how much variation kind of existed within our state and over time, to kind of better guide recommendations for testing co-product feeds. And so when we think about co-products, and what I mean by those is they're feedstuffs that are produced from the manufacturing or process of other industries. Things like distillers grains, corn gluten feed, soybean hulls, etc. Most diets that we formulate today for the beef industry contain at least one, if not multiple, co-product based feeds. And the idea is that because they are quote unquote a waste product from some other industry or avenue, these feeds can often be economical to feed, and that's why they become so popular. I used to joke that I never formulated a ration without dried distillers grains. It's always been something that's available, and it's usually a pretty good value. Even here in Kentucky, where we have a lot of the bourbon distilleries and at least one ethanol plant that produces those distillers grains. There are some disadvantages to co-products. Geographic availability, for example, cotton products. We have a few people right along the very southern border of Kentucky with Tennessee that may feed some cotton products, but not very many, certainly not as many as we see down in Tennessee and into the deeper south. Another thing to think about is transport and handling challenges, especially as we think about transporting high moisture or liquid type feedstuffs that contain a lot of water. Sometimes these co-products have seasonal availability, and there can also be some issues with consistency. And those are all things that we need to kind of think about when we think about using co-products into our feeding program. Because certainly availability and consistency are 2 things that we want to make sure that we have enough when we're setting up our feeding program, that we're not just going to unexpectedly run out or unexpectedly not be able to get the next load. And then obviously consistency of the product that we're getting would be important as well. So we went through, as part of this project, had several county extension agents throughout the state work with some of our local feed mills, and they collected monthly samples for about a 6-month period. Some of these products, ironically enough, became unavailable during that process because of plant shutdowns and things like that, and so we missed a couple months here or there. So you'll see a couple tables that are set up similarly to this. So this N value up here is how many samples were actually included in this. And then I calculated the mean. And then what we call a CV, which essentially helps us understand how much variation there was in these samples. So the larger the CV value, the more variation there was in these different samples. And then down here, I have a reported book value. So in the case of dried distillers grains, that book value comes from the NASEM nutrient requirements for beef cattle resource. And so you can see, just kind of looking between the average and the book value, that these samples were pretty consistent. Protein was a touch lower in our samples, and energy was, the net energy was a touch lower as well. Some of that can be based on just the equation that was used to predict net energy. May have been, there's multiple equations that could cause some differences there. And so, but if we kind of look through here, we do see that some of our nutrients were much more consistent. And anything that's really, with this small of a data set, anything that kind of ends up between that, 15 and below, I'm usually okay with. Because like I said, this is a relatively small data set that we're dealing with. What I find interesting, though, is when we go to something like wet cake or wet distillers, we have a few less samples here, but we see maybe a little more variation in that protein content, even though the average and the book value are very much the same. We can see a little more variation around that, and we certainly see more variation with the dry matter or moisture content as well. Stillage is one that we get a lot of questions about, and so in this example, we are using a book value that came from one of the University of Kentucky Extension publications, and to compare these back to. And again, we do see some variation, especially with fat. And one of the things that I want people to kind of think about, especially with this feed stuff in general, is that it can be kind of high in fat. The average was 15. There was quite a bit of variation in the samples. And again, it's a small number of samples that we're dealing with, so I try not to read too much into it. But fat is one of the things that can kind of limit how much of this we want to feed. If we get too much fat in the diet, in the total diet, we can end up impacting fiber digestion. And so in these high forage diets where fiber is very important as a way to add energy to the diet, we don't want to do something that's going to negatively impact that fiber digestion. And so that variation that does exist with the fat content is something that we should be aware of. The other thing, and it's not reported here because we just didn't have enough samples that reported that value, but another thing to think about on some of these feedstuffs, not just stillage, is the sulfur content and that variation that can exist. If we get high sulfur in some of these diets, we can run into some issues with a copper deficiency or even polio in cases where it becomes quite elevated. So those are things that make me want to kind of keep an eye on what it is that we're actually feeding and what those values are from our sources. So as I kind of put all this together, a lot of the dry co-product feeds, they appear to be pretty consistent, and more so than maybe our wet feeds, especially when it comes to that moisture value, which really becomes important when we think about how much of that feed we're actually going to deliver and thinking about formulating these diets. So what I tell folks is if we're purchasing commodity feeds from local sources that are dry ingredients, we may not need to test those as regularly. They do seem to be pretty consistent with existing book values. But if we're switching to a new source of that product, or the product appears to be different from load to load, then those are certainly things where I would want to consider purchase or looking at those feeds a little more closely. If we're purchasing a mixed feed that's got a guaranteed analysis on that tag, there's already some testing that occurs with regulatory services to ensure that those feed label guarantees are being met and are accurate. And so that becomes a little bit more of an opportunity to kind of to check the content that is in there. Now, keep in mind, not all of those nutrients I talked about are on a guaranteed analysis. Certainly protein is one of them that is. And so if we are purchasing those feeds that have that tag, there is some testing that does occur of that. Now, I talked about this moisture content of the wet feeds and why that can be a little bit more variable. And it's really just based on how much moisture there is. That moisture content is taking up a bigger proportion of the feed. And so when there is a change in that moisture content, it is changing. It's a larger portion of the total feed matrix, if you will, that is changing compared to in this kind of drawing over here, where even though the moisture content doubled, it's still a relatively small proportion of the entire sample. So with wet products, I do want to make sure that we're testing those probably a little more often, whether that's once per load. Bigger operators, that may not be practical, once per month, or if we're switching from one source to another, and adjust the ration accordingly. So in this example, if we had a diet, for example, that we were feeding 5.5 pounds of wet cake, but that 5.5 pounds is on a dry matter basis. In a situation where we have 40% moisture, that might be like feeding almost 14 pounds. Whereas when we drop down, I'm sorry, I said 40% moisture, I meant 40% dry matter, we would be at about 14 pounds of as fed. When we get over here, and we have more like 28% dry matter, that goes up to about 20 pounds of as fed. And so if you start thinking about that, if your moisture changes, moisture content increases, or is that you can ultimately end up shorting cattle on total nutrients because you're ultimately supplying more water. And this is a really good example of that. This is some work that from some work I did as a graduate student, and the purpose of this study had nothing to do with moisture content of feeds. This was just something that sort of happened along the way. And so each one of these little points on this graph is a day, and it's dry matter intake. And I pulled out 3 steers from this study. There was about 100 animals on it, but I pulled out these 3 individuals just to kind of show what happened as part of the study. And so you'll see that individual intake changes day to day. But in general, starting over here at the beginning of the study, it starts to kind of creep up. So it is slowly increasing, as we would expect it to be as the cattle are growing. And then all of a sudden, this dry matter intake drops down significantly. And what happened here is that these cattle were on a diet that was 85% corn silage. So vast majority of their diet was a very high moisture feed. And when we went from one bag of corn silage to another, that silage was from a different source, harvested under different conditions, and it was about 10% more moisture than what we had previously been feeding. But that was not accounted for when we were making feed deliveries to these cattle. So when we put it all on a dry matter basis, we actually end up shorting them quite a bit because we were ultimately just supplying more water. So the same total pounds was being delivered on this day as this day, yet we see this huge drop off in dry matter intake because essentially they were just being fed more water. And so that's where, especially if we're feeding high levels of high moisture feeds, we want to make sure that we do have an understanding of what our moisture content is, because it can really impact our feed deliveries. Whereas, we may have something that goes from 88 or 90% dry matter, 10 to 12% moisture, that type of change is very minimal compared to these much more wet ingredients that we can see. So I do encourage people to kind of keep an eye on that. And there are some strategies to measure, at least measure moisture content on farm, if we're not at least sending a sample out to the lab to be analyzed. So now we're going to kind of switch gears here and really talk about pastures. So there'll be kind of something in this talk for everybody, I hope. And really trying to assess fescue toxicosis risk in some pastures in Kentucky. We talk about fescue toxicosis a lot, but we've never really done a wide survey of Kentucky pastures. How much fescue is in there? How much... what is the risks of cattle consuming those pastures? We kind of just assume that it's everywhere, even though for many years now, we in Extension have been advocating for interseeding of clovers and trying some different warm season forages and things of that nature that can help alleviate fescue toxicosis. And so we wanted to go out onto several different farms and kind of do an evaluation of the pastures. So when we talk about fescue toxicosis, of course, we start with having fescue in our pasture. That fescue may contain what we call an endophyte. That endophyte is a fungus that lives inside the grass, so we can't tell just by looking out what grass has endophyte, what grass doesn't have endophyte. And to further complicate that, there are some endophytes that are helpful to the plant that don't harm the animal, and other endophytes that are helpful to the plant that do harm the animal. And those that do harm the animal produce these compounds that we call, as a family, ergoalkaloids, but the most prevalent is ergovalin. And so when we test pastures for ergoalkaloids, a lot of times we're testing for ergovalin, which is this particular compound there, and it's that ingestion of ergovalin that causes all of the symptoms that we see with fescue toxicosis. So looking at cattle that are in puddles or ponds that they have access to them, of course fescue foot, because we have that restricted blood flow to the peripheries. That decrease in blood flow causes necrosis of that hoof tissue. And then, of course, reduced weight gain in those cattle that are on an endophyte-infected fescue pasture. And I apologize, my citing here got cut off, but these are from one of the fescue toxicosis extension pubs that UK has as well. So to try and assess risk of fescue toxicosis, we kind of took a multi-step approach here. And the first one was to try to get a handle on how much fescue is actually in the pasture. So we did botanical composition of the pasture. So we start with a livestock panel that has 4-inch square spaces on it. And we cut out a section that is 5 rows by 5 columns. So we end up with 25 total cells. And what you do is you go out in your pasture, you randomly set that down in about 20 locations, depending on the size of your pasture. And you look in each cell and you record the dominant species that is there. So you'll kind of see that we certainly have more clover per se in this cell than we do over here. And so we have a little sheet that we go through and we quickly write those down. And then we can kind of calculate the prevalence of any given species in the pasture. Then we test for the presence of the endophyte. So not every fescue plant in the field may contain an endophyte. So we say typically that infection rate is about 60 to 80% is what's reported in the literature. And then we can test for how much ergoalkaloid is actually being produced by that endophyte. And that kind of gives us an idea of the toxic load that those cattle may be consuming. So if we start with having what percentage of the pasture is fescue, what percentage of that is endophyte infected, and how much ergovalin are they consuming, or how much ergovalin is present, then we can estimate the total ergovalin in the diet. And so I wanted to kind of show you what this looks like. So this was botanical composition from 18 fields on 8 farms. These samples were collected anywhere from about May to June of 2024. So F is fescue, then we have orchard grass, bluegrass, clover, other grasses, weeds, litter, and bare spots. And so you can see that predominantly our pastures were fescue, but we do have some clover mixed into those pastures, and there is a lot of variation in these pastures. So the average was 63% fescue, but that ranged from 5 to 94. So similar to the co-product feeds, that CV value here and SD as well is really an idea of the variation that exists. And so we certainly have quite a bit of variation that exists in these pastures. But keep in mind, this gets a little bit skewed because some of these just had nothing up to 9%, or some of these had nothing in quite a bit of some of these pastures. So that kind of does skew things a little bit. But if we then look at the ergovaline content of these pastures, so we collected the tillers and sent them off to be analyzed at the lab. So that averaged 544 parts per billion. The lab that we use, the test, has a sensitivity of 100. So if it's below 100, we just get the result of less than 100. And then the maximum that we saw in this sample was 1,005. And again, we see that we had quite a bit of variation across those pastures. I don't have the endophyte infection rate data completed yet, so for the purposes of this talk, I assume 70% infection rate. If we remember, the literature suggests anywhere from 60 to 80, so I met in the middle. And so by doing my math of what percentage of the pasture is fescue, and how much of that contains an endophyte and how much ergovaline is being produced, the ergovaline in that diet came out to be anywhere from approximately 0 or null up to a maximum of 645 or 644 parts per billion. So by accounting for how much fescue is actually present in the field, we see an average of a 57% decrease in that ergovaline load that's available for those cattle to consume. But we'll talk about some limitations of this setup as well, and some things to kind of keep in mind. Just to give you guys some context, the literature will suggest 100 to 300 parts per billion of total diet might actually be enough to induce fescue toxicosis symptoms. Other data suggests that it needs to be upwards of 750 parts per billion in the total diet. And so when we start to add in factors that make fescue toxicosis symptoms more severe, like heat stress, for example, then we may really need to err on the lower side of that range. So based on that, I'll show you in a minute some kind of categories that I set up to kind of classify these pastures. I do want to talk briefly, though, about some of the limitations for this. This is not perfect science by any means. These results really only hold true for that moment in time. The botanical composition is going to change throughout the year. I could have gone to any one of those pastures today. I wouldn't recommend doing that work on a day like today, but I could go out there today and get very different results than what I maybe saw in May or June of last year. Likewise, I could go out in, October, November and get different results. That botanical composition is changing throughout the year. And so we need to make sure that we think about that when we are selecting the time of year to collect these samples. I mentioned that we went out in May. May-June timeline is historically one of the times when we have the highest level of concentrations. So this is some work where from some of our colleagues in the forage group here at the University of Kentucky, where they went out and collected samples from the same fields at different times of the year to look at that variation that exists in ergoalkaloid or ergovaline content. And so certainly if I had collected samples up here at the peak, then that would be a good indicator of the potential overall risk of fescue toxicosis from ergovaline load. But depending on things like pasture management might dictate how much fescue I have present at that time. So I do encourage people to use this, with some bigger context as you kind of think about, what other factors are going on in your pasture. The other thing is for example, one of these pastures only had 5% fescue. And so regardless of the time of the year, you don't have to worry too much about that fescue not providing a major part of the animal's diet. But the other thing that we haven't looked at is animal grazing preference. So in these pastures, then where we end up with, closer to 95% fescue, chances are they don't have a lot of other option but to eat the fescue that's there. But in some of these where we have maybe lower or lower ergovaline concentrations, a little bit lower fescue pressure, then those are certainly fields that maybe develop a lower risk. So you want to kind of look at all of this together and trying to understand how much they may or may not be consuming. So after I kind of estimated their overall ergovaline intake, based on the existing guidelines of, potentially 1 to 300 parts per billion causing a problem, and certainly anything over 750 parts per billion likely causing a problem, I kind of categorize these as anything that was less than 100 parts per billion of that total intake, so also accounting for the presence of the fescue. I classified that as low risk. Anything that ran in that 100 to 300 parts per billion was a potential risk. Anything that was between 300 and 750 moderate, and high risk was higher than 750 parts per billion. So in this set of data, we didn't have any that came in at high risk. That's not to say that cattle on those particular pastures would not potentially develop fescue toxicosis. It's just a kind of an assessment of the risk, if you will. And likewise, even on those low pastures, that doesn't mean that at some point in time in the year, or given the botanical composition or animal preference, or our animal grazing management, for really forcing forage utilization and intake on those pastures, we may could run into a situation where that total ergoalkaloid intake increases. One other thing that I kind of want to point out on this project is that we did have some fields that we knew were novel endophyte, and those did come back at less than 100 parts per billion. We had another farm that had 2 fields, and one of those we knew had more recently been reseeded with Kentucky 31, and the other one was the other field was a very old stand of fescue that had been there at least as long as this producer's been running cattle on that particular farm. And so when we look at those, the newer seeded Kentucky 31 actually had very low levels of ergovaline, whereas the old stand of fescue had really high levels, like around 900 parts per billion, with the new stuff being less than 100, which was similar to a lot of the novel endophyte samples that we had collected as part of this project. And so, I think there's some interest in trying to understand, what does a bag of Kentucky 31 really contain, because we know it's not necessarily a guaranteed or certified variety, and so there are instances where you buy that bag of fescue seed and it's not necessarily Kentucky 31. It may not be as hot as Kentucky 31 traditionally is, and so there's some work I know being done by forage colleagues to kind of better understand that and better survey that, because that's really just some observational conversations that have happened in the research community over the last couple of years, is trying to understand what is in these bags of seed, because we have some researchers that want to feed fescue seed in their projects to get a specific dose of VanValin delivered, and may have difficulty even finding those particular bags of seed that are hot. And so it's just kind of interesting, something observational that we saw here in this project that kind of follows with what others are starting to report as well. And the last topic I wanted to kind of touch on was assessment of conserved forages. So hay, silages, baleages, etc. Variation certainly exists in conserved forages. These are some dry hay samples from the 2023 Eastern Kentucky hay contest. And these are just grass hay samples. I pulled out anything that was a legume, and we've got the crude protein content and the energy content on about 223 samples. So you can see quite a bit of variation exists across these different samples of hay. And if you start thinking about feeding some really stemmy, mature type hay versus something of some better quality, even at lower inclusion levels, at 35-40% of the diet, or even, a little bit lower than that, we can see impacts on performance of up to 1/4 pound per day on predicted performance, and just based on the energy content being provided by the hay. So testing hay samples is always recommended because there is so much variation that can exist there. And certainly the more forage we have in the diet, the larger the impact of that variation can have on the total nutrient content of our diet. So things to consider when we talk about testing forages, the results are only as good as the sample that we collect to test. So we want to use proper sample collection and handling techniques to make sure that we get a good representative sample, that we're using a good hay probe to get a cross-sectional sample of that bale or into that silage pile, if you will. So making sure that we get a good representative sample of what we're feeding, because we're going to make some pretty important feeding decisions based off of the results of those samples. Using labs that are certified through the National Forage Testing Association, those labs that carry that certification, they do go through some quality assessments from time to time, making sure that their techniques are getting good results and repeatable results that we can trust. And understand that these labs may have upwards of 15 different tests to choose from. I know in Kentucky, a lot of our county agents assist with hay testing programs. And so I tell producers to work with your county agent, and certainly those of you joining us from Tennessee, I know you all have a great network of agents as well. So I encourage you to work with them in helping determine what test it is that you need to submit. But in general, those tests come in two main categories. They're either going to be what we call an NIR, or near infrared spectroscopy, or wet chemistry. There's a whole host of differences that we could do a whole talk on just on that. And so what I tell people is that in general, NIR is good, but also in general, wet chemistry is better. NIR is typically cheaper. It's typically faster. If you're working with a good lab and you're sending in something simple like a grass hay sample or something that's known what it is, then NIR can work really well. When you start getting into mixed samples that may contain some grass and may contain some legumes, the equations that they use for NIR are really dependent on what is in that sample. And so if it's something that's mixed, you may want to use wet chemistry. Also, if we're doing anything that's like a ensiled feed, I always encourage folks to do wet chemistry and add on what we call a fermentation panel that allows us to see the pH of the silage, as well as some of the acids that get produced as a result of the fermentation process. It helps us have a better understanding of whether or not the ensiling process was good and effective, or if we maybe have some issues, and it can indicate that we may have issues with clostridial fermentation, which we know can at times lead to botulism in cattle. Or it can even let us know that, hey, that fermentation wasn't all that great. It's probably safe to feed, but may not preserve as long as it otherwise would had the fermentation quality been a little bit better. So there are certainly some things that we can learn about the ensiling process from doing that fermentation panel. So I always encourage our folks to consider sending those types of samples out for that. So to kind of wrap this up and understand what it is we're feeding, co-products are certainly economical feed sources, but availability, transport, and consistency can be something that we need to consider. Most of the ones that I showed here today were relatively consistent for at least some of the nutrients that we talked about. Those high moisture feeds can be more susceptible to variation just due to that moisture content. And I didn't touch on this, but it's not only the moisture content with how it gets delivered to your farm, but depending on how we store it, that can cause other issues with additional moisture being added to those feeds, and that kind of thing as well. So that moisture content, though, can certainly impact the nutrients that we're delivering to our cattle. From a fescue toxicosis or a grazing standpoint, if it's something that you believe you've had issues with, if you know that you don't have novel endophyte on your pastures, it may be something worth considering to assess your pasture risk. The testing for the VanValin and the presence of the endophyte are not necessarily the cheapest things. I know the University of Kentucky's diagnostic lab runs those tests, but there's also just some issues with making sure we get those samples collected and properly stored properly and don't let the compound degrade. So it's certainly not something we got to kind of collect them and get them put on ice. We don't want to let them hang out and that kind of thing. So if that is something that you're interested in or believe that you've had some issues with fescue toxicosis, I know we've had several cases of fescue foot in the state of Kentucky over the last couple months with some of the winter weather conditions we had. That's certainly something that I encourage folks to consider. And then lastly, don't forget about the quality of stored forages. There's can be a lot of variation that occurs both in dry hay and silages that can certainly impact animal performance. If we start, formulating because we think it's this value of quality, but it actually ends up being, much lower than what we predicted, then we can actually end up kind of underfeeding. So when we start thinking about formulating rations and working on refining our nutrition program, we need to think about that entire time span of different diets that can exist, and making sure that we are limiting the variation or error that we as humans introduce into the equation, because there's certainly enough that we don't understand about animal preference and what they're doing on their end, that if we're causing issues right off the bat because we're making the wrong assumptions about what is being fed, then we can start to cause some error in terms of what it is that we're actually feeding. So with that, I'm happy to take any questions that you all might have for me, and I thank you for joining us again this evening.